Isn't they can't see that? That's why I put it.
Yeah, just put it.
Alive?
Oh. What?
Hi guys, welcome. This is Amanda Armagast at Essence of.
I'm Melissa Hopper.
And I'm Dr. Abbasi. It is end of October. What happens end of October?
Spooky season.
I heard that it's your favorite holiday.
It is my favorite
Why is
holiday.
that?
I just like the vibes. I like dressing up. I like being spooked. I'm not really into haunted houses because, like, I understand that that's not real. But what we're going to talk about is truly spooky.
Now, Alyssa, tell me about in the spirit of Halloween. What is the spirit of Halloween? Why people like to be scared, or why do you think what it is? Why do you like Halloween? Do you go?
I like Halloween.
Do you like scary movies?
I like scary movies.
What do you like about that?
I think when Halloween comes, it's just a different vibe. Like she kind of said, like it's a feel, it's a vibe that you don't get at any other time of the year. It's an excuse to, like she said, dress
and
up,
be weird.
have fun,
It's an excuse to be weird.
You know, give an excuse to eat tons of candy, chocolate. I guess for me, it's more of a tradition. It's one of those things that it's less of, what is Halloween or what is behind the holiday of Halloween. It's more so like, it's how I grew up. It's a tradition that I had starting from a young age.
Right.
But why do people like to be scared?
Well, I think people like to be scared from Halloween because they're safe.
No, but they feel safe, so they're okay to be scared. But why do people like to be scared? Why?
Adrenaline. It's a
Roller coaster.
It gives your body that rush. But like she said, like, you're okay, you're safe. So it gives your body that sense of like, and then you get
Relief,
this like, these endorphins running through your body, but you're going to be okay.
Yeah,
so
like,
it's fine.
like,
it's fun.
Like roller coaster. You're going down. You know you're going to be safe, but your whole system goes through a flight and a fight response, which is adrenaline rush. We have a word for it, adrenaline rush. People go free climbing. People do this and that. So we, in a way, our body needs a little bit of excitement. Our regular life, we don't get enough. It seems we don't get enough of it because that's why people do crazy stuff to, like skydiving or parachuting or climbing and things. Roller coaster. I mean, look at that. People, a family of 4 pays now almost $1,500 for a day in Disney,
Right,
or Six Flags or something like that. So we pay for it. Be scared.
Oh, absolutely. People pay a lot of money to be scared.
Well, yeah, think about those haunted houses. They're like in Minneapolis, some soapbox, they have a haunted house that you have to like sign a disclosure that it's okay if they touch you and you won't sue them.
Oh, okay. Well, yeah, okay. Yeah, that's what they pay for, to get scared, and they want to bring all the elements of, what scares? What is this is the essence of medicine. What is a pathology, or what is it, and the normal physiology? The catecholamine kind of relief, adrenaline rush. We call it. What does adrenaline? Why do we? What is the reaction when you get scared? Start with that.
Well, your heart rate goes
so
up.
Yeah,
So
your heart
I was
starts.
thinking more like the sympathetic nervous system.
It is a
type
sympathetic.
of, your pupils all of a sudden, they dilate, you start getting the sweat, your heart, all those, typical
Let's start
hair
with that.
things.
You're on a good path there. So, what does your body want to do when you get in a fight and flight response? What does your body want to do?
It wants
you to fight or escape.
or run, yeah.
Okay, so what does your body need to do that? Amanda, you are scared, like you're in a path, somebody's running behind you, you're scared in your one of your, when you go walking sometimes and so on. And then when you're too scared, sometimes you call me. I'm not sure what I have to do, what I can do for you. Okay, so what does your body respond?
Well, you
What
need
does
to
your
think quick. That's one thing.
focus.
Mm-hmm.
Okay, what else? You're concentrating, you're blending out anything that's not really relevant, like your mortgage next month or your car problem and so on,
Yeah.
they all vanish away. As a matter of fact, it's more than that.
Hmm.
Have you guys heard that when a soldier, they go through a whole day of battle, when they come back in, they have bullet holes in their legs, they didn't even notice
Yeah,
that?
they're pain.
You're suppressing the pain response completely. Your brain disregarding, like a huge gap in your leg, brain is disregarding that because it's not important in that moment for your flight and
Mm-hmm.
so pain suppression. Go ahead, you're on a good path. You focus on what really matters. Your heart
I am
start
on.
beating fast
Yeah, heart rate.
because your body wants
Needs to
to.
get blood flow to
Yeah.
the limbs. So
Yeah.
basically, one of the things
Everywhere.
that I was always taught was like, you sit all day, you don't need your limbs. Your blood goes to your organs, your internal organs, the digestive systems,
And
all
you
that.
got a parasympathetic
Mhm.
system, meaning the parasympathetic system literally shut down. You stop digesting. Many animals, when they're in that situation, they actually throw up. So they are lighter. They can go. So and it actually,
What animals do?
almost all
Curious.
animals,
Really?
like your Lily, growing up when you get excited. That is,
Yeah,
and
she
she's
threw up
excited
this
all the
morning.
time. Your dog,
Yeah, she threw up
she has a little dog, and that's the funniest dog I have ever seen. Look actually like a small little piggy, and is the toughest. It seems to be the toughest, but even the little chicken is.
She's not the toughest. She's the weakest. My chickens fight her.
Yeah, but every time she gets excited, and she throws up. Right? Sometimes she throws up just for no good reason.
Yeah,
So,
she does.
but it is when we get excited, the sympathetic system goes up, our sympathetic shut down, and then sometimes that just dead weight. Your body wants to do that. You want to get rid of. There's another thing,
You pee.
and you. Yeah, you should. Yeah,
They're
you
nervous.
soul yourself. Okay.
Is it?
Same reason. You want to get rid of, your body wants to get rid of all the dead weight. That animal do the same. They literally defecate and urinate. They have less weight to carry with them.
Is it only to get rid of the weight, or is it sometimes maybe conserve? Like if you have food that you're processing.
Both. This, you're surviving. You're at the survival mode. You're not about that they digesting. Like even that is so crucial, so original. Even the snake is in a bad. It takes them a week to digest the food or something. So in a difficult situation, they literally regurgitate the food out so they can escape fast. So, okay, heart stop beating. You're reducing the blood flow to your organ, but increasing it to your brain and to your limb. So, what else? What
Well,
happens?
when I get scared, my stomach hurts, and I feel like anxiety.
Yeah, that is the same thing. That is part of the same thing. Your stomach hurt because it's shutting down, and anything that's there is dead weight for you. It's not food anymore. It's just liability.
Also, like you said, we're not getting the blood to those organs. So that typical like peristalsis movement of like, your stomach, your intestines, like we said, it shuts down so that food is literally sitting there or slowly, something that would typically go faster. So that's.
Have you guys noticed many people when they get excited, they throw up? Many people who are in it, like if are upset or no, you don't notice?
No.
No.
Not anymore, I guess.
But sometimes, what about like when you're scared, you get
like fainting?
Yeah,
like
faint.
Like it could be more of like a
That is a
vasovagal type of
That is a
response.
different mechanism. We can come back to that, and I have a few things to say about that. But another thing you mentioned that is sweat.
Right. I think I see that more as like, your body is always trying to have the homeostasis. When you get, the way I saw it was when you get in that reaction, your blood vessels dilate. You try, they come closer to the skin. That's why you get red, your face, you look hot, and your body tries to regulate that by releasing sweat by cooling your body down the only
Your
way it
body
knows
knows
how
you're going
to.
to run fast. Want to cool you down.
Mm-hmm.
So how do we cool it down? Sweat.
You sweat.
Yeah, so you see that's such a like an orchestra harmony of preparing you to survive.
And what's crazy is like you said, it does that before you even run, before you even have the chance to
It knows
fight
you're
or
probably
flight.
going
Your
to run.
body knows
Yeah.
you're about to make a decision. Here comes the sweat. Here comes the racing heart. Here comes the laser focus. Yeah, before anything even happens.
And actually, the solution for that is easy. Those species that they didn't do that, they overheated and died. They didn't reproduce. So only those left that are prepared for this situation. So, but we like it. That's the crazy part. That since we in a real life, Alisa, did you have a good piece of meat yesterday? Did you eat a piece of meat, nice piece of meat? Where did you get that meat?
Where did I get that meat?
Yeah.
I got it from a restaurant. I had pad thai, so
I'm
chicken.
jealous.
Did you have to chase it? Did you
I
have
did
to
not.
fight for it?
I did not.
So,
I had to chase some meat.
yeah, no, but you
Yeah,
can eat meat. You're a vegetarian.
Some
No.
live meat.
Yeah, but that chasing behind your chicken, that doesn't count. But that is something our body actually needs. This chasing, these episodes of high intensity, our body, our heart, our lung, and so on. We need our body always prepare us for the maximum, and we don't get it enough. That's why people go for, literally drive half an hour to a gym, and we go to gym, we do whatever we need to do, then get back to the car, drive half an hour back. Where, maybe a few hundred years ago, you had to go and get your water. You have to run half an hour to get your water. You got it in your life, those kind of activities. Now, you have to create those moments for, okay?
Yep.
Like, there is a meme, I watched it in one of the social media, that there's a jogger running around, and the wolf is saying, what is this top predator doing?
Right.
And the bear is saying, hey, you have to conserve energy. Are you crazy? And so on. And the other top predators say, what are you doing? But for us, because we may get our meat from a restaurant or a supermarket, that is something we really crave and need because our body needs it. So in that sense, Halloween is a good opportunity for all of us to fill our tank of excitement and so on, in a mostly safe environment. Okay. Now, let's talk about spooky things. Okay. Tell me a few spooky things you are aware of, and let's just dive into find the mechanism of that. Like, you have lots of things about zombies, right?
Oh.
And we have lots of
that kind.
monsters, zombies, dead people, or creepy animals, and so
Or
on.
people coming in your dreams, people coming to your bedroom, like the person who used to own the house and he passed away.
Ghosts.
Yeah,
and so
ghosts
on.
and spirits.
Yeah. Let's talk about few of those things. Like, is it possible for a dead person come back to life? I mean, if you're in medicine, I mean, that might sound trivial to us.
Well, I mean, yeah, that people have come back to life.
Oh, tell me
possible.
about it. Tell me about it.
Well, I read a book one time by a heart surgeon, and I read it so long ago I don't want to read it, but he basically had a patient, and
What does that mean? What does that mean?
his heart stopped.
Okay, see that there? Yeah, go ahead. I'm going to come back to that. So the heart of this patient stopped.
But a lot of other things went wrong, like some things got unplugged and stuff, and the doctor had to like crawl under the table. All this stuff happened, but the patient was brought like back to life, and supposedly never knew all the stuff that happened when he had passed away. But then came up to the doctor and was like, "Why would you do all that? Why did you save my life?" Like, he was miserable, and he told the doctor that he watched him plug all that stuff back into life. So
Okay.
that's my interpretation of coming back to life.
So let's talk, Alyssa, you and I talk about the medical part.
Okay.
What is a medical and medical legal definition of death?
Okay. The lack of electrical activity within the human body. Like, so
Human
like
body,
brain.
brain. Now, for a very, very long time, the definition of death was when your heart stopped beating. But that's something we can easily measure, right?
Mhm.
And but now we have people who don't have a heart; they have a pump instead of a
Mhm.
heart. For people who get surgery, cardiac surgery, that we make their heart stop beating, and we put their blood through a, the cardiopulmonary kind of bypass.
Mhm.
So they are not dead,
Right.
even though their heart's not beating.
Stops.
So we have come away from the irreversible cessation of brain activity in the brain is in most of states the definition of death. Now,
Mhm.
like I'm a neurosurgeon, but they always would call me in a questionable situation to come and pronounce death. What are those questionable cases? Why is it anything questionable? Because the heart's still beating,
Mhm.
but like somebody has such a massive brain injury that even though the heart is beating, that patient can be pronounced dead even with the beating.
Mm.
You know how we would, you know what the steps are to pronounce somebody brain dead, which then by definition is equal to actual death of the person?
I don't, but I'm guessing you would have to do some sort of test to check for electrical stimulation within the brain.
Okay.
So I'm thinking like what probing, putting something on their head to check to
Mhm.
stimulate
Yeah.
and
So
check reaction.
let's come to the basic of that. You have to prove that the brain is irreversibly has no function.
Okay.
What easiest way it is to see if the brain has any function at all? Very good, actually. Now, there are certain responses that are so basic, patient can be even in coma, but like you still can provoke those responses to see if they're like, or pupil reaction is one of them.
Mm-hmm.
The other one is so-called the caloric thing, where you fill the ears with cold water and you see if they have nystagmus.
Mm-hmm.
That is so basic. That's brainstem. Meaning, if that doesn't work, your brainstem is gone. Then it's so basic response to pain, but that can be sometimes difficult. Somebody's in deep coma. But another thing that is extremely basic, that it's you cannot miss that, is what we call hypercapnia. You know what that is?
Uh, hmm, I do, but
Hold your breath for a minute, see what happens. It is like your whole body is asking for you to breathe.
mm-hmm.
You know what that response comes from? From a higher level of CO2 in your medulla oblongata and brainstem that gives you a signal to your whole brain, stop everything you are doing, take a breath. Makes sense.
Mm-hmm.
If that wouldn't be that crucial, you quit breathing and you die.
Mm-hmm.
Now, what we would do in a situation like that, patient is on the ventilator and we do other tests and so on, but we would actually hold breath and measure every minute or two, almost every minute, take a blood sample and check the level of CO2 in their blood.
Okay.
If the level of CO2 is above certain level and they still have no respiratory drive, meaning that then that it's enough to cause them brain death. So hypercapnia, the test, the caloric response, the motion in the eye, the pupil response, and so on. But there are other ways. You can put them on an ECG, electroencephalogram, and you just have the brain activity. If it's flat over a certain period of time, and they're not on some other medication that would suppress that, there's some criteria so that they have to be off medication and so on. Or you can do as well a cerebral angiogram. If you see that the brain is getting no blood, if the brain is dead, shut down, and you're not getting any blood, then it's enough. Now there are some other things like MRI, CAT scan with some other variation that show that practically brain tissue is gone. They can be as well helpful. So coming back to that person who died on the table, his brain could not have been dead. It could be that the heart stopped beating, because if the brain literally doesn't get oxygen for 5 minutes, a cascade of things start that is not reversible. Is there exception to that?
I feel like there's an exception to everything.
Yeah.
And if he's
Yes, there is.
asking you for sure.
Then yeah.
Yes. Now, that 5 minute applies for room temperature. You fall in a cold lake or under an avalanche of like a snow and so on, your body cools down. People have been revived after 45 minutes of practically seizing their brain system activity to cool them down so fast that energy requirement, that cascade that start breaking down our tissue in our brain, start within 5 minutes in a room temperature. But if you cool that person down very rapidly, that cascade can be extended up to, people have been described after 45 minutes, 50 minutes. That person is truly, for all medical standard, dead for 40 minutes, and then we bring them back to life. It's a huge thing to do that. Like, you know who's good in that? Swiss are good in that because they have Alps, they have lots of people get in avalanches and so on, and they have come up with these protocols and so on that they open you up, they put your heart, they circulate you with things and so on. They have come up with good protocol to do that. But beside that, 5 minutes is the limit. Okay, well, lots of medical information, but I want to know few questions, spooky question you have for me, and I try on the medical side to dissect it and give you some information.
That's a spooky question.
Go ahead.
Could you, so you can do different types of, I mean, not you, doctors can.
Head transplant.
Yeah, can you
brain
talk about,
transplant.
can you talk about like a head transplant? Like, I don't know, imagine if you got eyeball transplants and how you had memories from like visions like that.
So, Elsa, what do you think? Head transplant.
I mean, I know they can do like face. I've seen face transplants. Taking this and taking that, and I know that the world is growing so fast, and I would not doubt that a brain transplant or some sort of future head, whatever. I could see that coming.
It's not
right.
Future, it's past.
They've done a full head transplant before.
Not on a person, but on dogs.
Oh, okay.
But
Wait.
You see that there? Now, let's be clear about that. If I take your arm and put it on somebody else, or if I take your heart and put it on somebody else, is it you or is it that person that is surviving?
That person.
That person. So if I put your head in somebody else's body, is it you or is it that person?
It would be that person.
No, it wouldn't be. It would be you.
Oh gosh.
It's not a head transplant,
Sure,
it's a
if
whole
we're
body transplant. That's what it is.
With the brain. So you would
Yeah.
keep same memory, same personality.
Yeah,
You would
It's a
think,
brain. It's a brain.
assuming that the surgery
You are your
is
brain.
uncomplicated.
No. So there is no head transplant. There's a whole body transplant.
And the only
Hold
thing
Hold on, I just
person-
want to put this into, so
Your head.
a red car and a blue car get into a car accident. The head, the brain of the person in the red car is fine. Then the person in the blue car, they're dead, so you take their body and put it on.
Very,
That's what you're
very
saying.
visual description, but yeah, go ahead. I like it where it's going. Go.
Well,
we just would transplant the brain.
The head
of-
is the person. Your memories, your
Yeah.
personality doesn't come from your shoulder or your heart and so on. It comes from your brain.
no, mine comes from my heart.
Yes, but still legally, it's a whole body transplant. No, and they did it in 1970s. The Russian did it in 1970s on dogs. They survived about a week or so, 5 days.
Okay.
It's legally and practically ethically, it's very contentious area. Some people have now came with some protocols and so on to do that. First of all, that whoever you're going to do that with is going to be paralyzed next, because we don't have the technology to connect the spinal
Spinal cord.
so you can control that. The rest of the body works actually, surprisingly, the rest of the body can work without it okay. You see, you need like a mechanical ventilation because your brain is not controlling your ventilation
Stimulate.
anymore. But the heart is more or less by its own. Or your GI tract has its own nervous system. They call it the second brain actually. That can as well work on practically your body become like a nutrition pumping producing machine for your brain. You have to mechanically ventilate because your you need the brain stem to ventilate your breath and so on. But it's possible. Technically, it's possible. And then you have to connect. You remember yesterday where in our cadaver lab we talked about the 4 vessels that give blood to the
Your
brain, and 2 or 4 vessels that actually take the blood out. Jugular veins and carotids. And our technology is good enough to do that. And but I think that is a very contentious area. It's technically possible, but we don't really dare to put it in actual use, because it would be a very, very extended surgery and multidisciplinary and so on. And the result of that is somebody who is quadriplegic. So
yeah, and if the dog can only survive 5 days, what?
exactly. Except advance of science, but what is the border between advance of the science and our ethical responsibility? But that is a good question, Now the question is, can we take somebody's head, attach it to a different machine that just sent oxygen and so on there?
Yeah, that actually brings up my next.
Yeah.
Already.
Yes, go.
Walt Disney, how he shows himself
Mhm.
about that of people, and then because he believes that he's going to go back to life, right?
Yeah, well, let's talk about when we die, what makes us just what happens to the brain? Mostly brain. The rest of the body is catch up with that. But what happens to the cells at the cellular level when we die? What happens?
I guess this may not be like medically correct, but basically to me, like it melts, it disintegrates. It was
Liquefies.
Oh, there you go, liquefies. Like it
Our
becomes.
brain liquefies, and in that process, what happens is, first of all, with no glucose or potassium, sodium
Pumps.
it cease working. That means that the potassium goes out, sodium goes into, and at that point, the equilibrium of those membranes is lifted. Then in each of our cells, there are those vesicle, Golgi apparatus, and so on, that have enzymes. Those enzymes cannot be held in check anymore.
Sure.
They start digesting you from inside. Yes. Is that spooky or what?
Yeah, that's really spooky.
That
so
is the
basically
mechanism
you start eating yourself from
you
within.
fall apart. Well, not eating, because eating would be like
Chewing.
well, as well
have
absorbing
to
the
be
energy.
alive too.
But the enzymes that helps you to do your cellular function start digesting you from inside. That's the liquidification or whatever it's called of the brain, and that happens in the brain first and foremost, because believe it or not, 40% of your energy that your body produces goes to your brain. It's a very energy hungry organ. Okay?
As it should be.
Yeah,
Yeah.
right. It's kind of
For most of people.
Exactly. For most
Yeah, good
people,
point.
we would.
So in that sense, imagine if we stop that process. Like there was the movie with Sylvester Stallone. I love that movie. It's called it's something that I forgot the name, but they have a machine that they cool them down like in a fraction of a second. By doing that, they can make them thaw them out many, many years later and so on. Demolition Man, yeah, it's what's called Demolition Man. Okay, there is a thing that when they try to freeze them, there's something that when they touch that, all of a sudden, in a fraction of a second, everything freezes, and they thaw them out. Somebody put good amount of thoughts in that. Why can we not just freeze people and thaw them out? We can do it with frogs, we can do it with lots of organs like sea orchids, lots of one cellular thing and so on. You can do it with some animals. You can freeze a frog. Actually, some animals, that's the way of they survive in cold. Can we not do it? That is one factor, but why can we not freeze warm-blooded people?
Because I mean, in my idea is, blood is what's needed to give oxygen to everything. Your muscles, your brain, like everything we've talked about. So if you freeze that, then you lose that passageway of blood to your. Would that make a difference then? The muscle wasting, like we had.
It start with you're too big. You cool down fast enough that by the time you're starting to cool them down, they're still using energy. They run out of energy, and the cascade of damage starts.
Already starts, right? Okay.
And even get worse because we are so big. When we start cooling them down, by the time we get to the freezing point, what happens when we get to the freezing point? Expand. Why do we expand when we get to the freezing?
We have so much.
What happens? It's
water
lowest,
expands.
Yeah, water expands because
freezes, becomes a solid. Yeah.
So if you want to know why it doesn't work with human, put a bottle of bottle of water in the freezer. Come back and see what happens. Go ahead, do that. Put a glass of water. No, it's safe. You put a glass of water in a glass container, which is sealed. Put it in your freezer. When you come back, it breaks. That's what it is, because it expands. That happens in that cell, meaning that it breaks the membrane and the organs that are inside of us.
Sure, it goes all the way down to the smallest unit of life. Like even just like that one cell expands out and breaks membranes, and then so if we were to freeze everything, that would break, but you're kind of frozen, so it kind of is held. Yeah. So is it the melting process or the thawing where you just kind of fall apart?
The freezing and thawing, in that process, we are not refined enough that some fish can do that. They have a protein that almost acts like antifreeze, prevents the building of those crystals.
Okay.
And there is another animal, very sweet animal, that has a different mechanism to practically go to hibernation, not hibernation, practically become unalive for 100 years, 200 years, and then come back to life. And those animals, they can live in the vacuum of the space and so on. It's crazy. You know what I'm talking about?
I don't, but I believe you.
Is it a cockroach?
No.
Is it an animal or?
That animal. Yeah. Called water bear, tardigrade. It's a very microscopic animal, very small, so sweet. If you look at the pictures of that, it's like a cute little teddy bear. It's very small. And what happens is it actually, in a very controlled way, first of all, it retracts its extremity. That's like 8 little legs, and it just goes on the
like a little spider, kind of?
It's not spider.
But it has 8 legs.
Well, it has truly 8 legs that it just moves and has a mouth and so on. That's why they call them water bear.
Water bear.
Go look it up. Go look up tardigrade or water bear. First of all, it retracts its arm, its appendix, and then it produces a protein that, in a very controlled way, it evaporates its fluid. It becomes completely dry. Then, when it's dry, then it becomes like something that it's just a package of proteins and fats and sugars, but there's no activity, no life activity. And it survived for hundreds of years. And then when it finds water again, absorb the water and start living again.
Like freezer dried, like astronaut type food where they dehydrate it, and then the second you add water to it, it puffs up and it's brand new.
No, we cannot do it with a human because our surface to volume is way different than a tardigrade, which is microscopic. Some fish and some amphibians, some fish actually do that by creating a anti-freeze-like material that prevent building of the crystal. So I wouldn't completely rule it out that in the next 100 years that we refine that process, that we first, somebody in that situation, we put a lot of that or replace your body fluid with that material, then pull you down, then is all the activity without losing any structure. That's what it is. Then when the time comes, we replace that again with normal thing, and then we revive you and so on. I don't see that. I don't believe that's impossible. I think maybe your children will be in a situation to see that technology.
At this point, wait for Walter because he's already
Yeah, it is. I think Walt Disney was a
excited.
little more hopeful than he should have been.
Is it his whole body that's frozen?
Let's go find out.
Yeah.
Let's
Go to the factory.
Factory is a
Go to
factory.
where else would it?
Yeah. So, Alyssa, do you have any spooky question for us? How long has it been? I think we are almost getting there.
Been almost
30
5
minutes.
minutes.
Okay, then let's have one more spooky question.
Fantastic.
Zombies.
Yeah, we can
Zombies?
talk about zombies. The origin of zombies.
Well, gosh, I think it's more so like, everyone's
Werewolf.
Vampires.
Come on.
Yeah,
Pick
well,
one. Pick a topic. Frankenstein.
I'm more on the topic of like the zombies, the zombie apocalypse, and more so some of these like, mad cow disease and
like flesh.
Let's
the
start.
flesh eating
Let's
that
start
viruses
with
that
vampire,
can come.
right? One of the oldest legend and so on is a vampire, right?
Of course.
Have you heard of that disease called Eczeroderma pigmentosum? This is a genetic
It
disease.
has to do with the skin
Yeah, the genetic disease that
pigmentations. So.
you lack a gene that produces an enzyme that repairs your DNA.
Okay.
Every time you go on the sun, ultraviolet, they break some of your DNA in your skin cell.
Hmm.
And you continually you're repairing that. These people are lacking that. When they go in the sun, after a week or two, it is like third-degree burn.
Mm.
Does it sound like familiar with the vampire?
Vampires can.
Now, let's talk about a different disease. Rabies. What happens with rabies?
But,
Bite them,
well,
bite
you-
somebody, and you give it to them.
That's how it's passed. Yeah.
Sound like familiar with?
Yeah.
Now, yeah, another thing. With rabies as well, there is a book that you can't really read about that. Like another thing that when somebody has rabies, that they become very aggressive. They want to bite people. There are two other things in that werewolf and vampire. They want to bite people, right? There
And
you
both
are.
of those, vampire and werewolf.
There you are. You are. So there are lots of different rare genetic disease that make us like people who have rabies. They cannot stand water. Have a fear of water. And they you give them water, they don't drink it, but they want to bite people. Can you imagine that? In a long time ago, people didn't understand that. You give them water, they don't want to drink the water, but they want to bite people, drink their blood. How all of this started, and so on. Yeah. So many of these, the fear that we have there came from our lack of knowledge of some very rare.
Where does the garlic and
Ways to fight vampires.
Yeah,
They
but
say vampires are scared of garlic. Like I've heard of that, whether
Yeah.
it's a smell or what it is that keeps them away. But you're supposed to put that on your doorways or in your window frames. Like I've heard that as
right,
well.
and like silver. I think the only way to kill a vampire is like silver
Or a stake through the heart.
Yeah.
Yeah, well, I think on the medical side, I think you can kill anybody with anything, any kind of stake through the heart. And but for them, it was probably something that to be sure that is through the heart and not some other organs, then they would survive.
What about garlic?
I don't know if anybody knows what the origin of garlic being something that keep the vampire away. I just know that when people have rabies, they don't eat regular food. They're actually their throat clamps, so they cannot eat anything. I guess maybe that they used to not being able to eat, and they thought, oh, maybe they cooked something with lots of garlic or something. So
No, garlic, it gets rid of.
yeah, that's why I'm saying that people who have rabies have what called laryngeal spasm. They cannot eat or drink anything.
Do you think it has something to do with like salivation stimulation? Like you had said, if you can't eat or you can't swallow. When I think of garlic or I smell garlic, I instantly salivate.
You do?
Yeah,
You're the only person.
Really, I love garlic. I love
Or-
garlic or pasta where you smell that,
Right.
you instantly go, I'm hungry, and you get that. Well, if somebody like that, they
Yeah.
would stay away.
That's
I mean,
a
that's
point.
just
Good explanation.
trying to connect any sort of
good
dots I
explanation.
could think
and
of.
it could be like global too, like scene-wise, who's seen the most garlic, maybe that area where vampires
Sure.
originated.
Maybe in Europe, that all of this probably come from Europe, Middle Age Europe. Okay, that was interesting actually.
Yeah, and one thing about zombies is that I want to hear you talk about. I don't know if you'll really be able to, like, they're really popular, right? Or not like popular, but people are worried about them.
The
And they've been
same,
recent times.
same concept as
Yeah.
it's like
The
a
prion disease.
yes, exactly, that attacks the brain, creates that the mad, deranged, and then they can pass it on.
Well, and apparently, if you hunt a zombie
eat it,
deer,
yeah.
you get sick from it. But I think their meat is also a different color.
There's a lot of speculations versus studies. I'm not so sure, but it's out there. I haven't heard about it
So
recently,
let's
but
talk
a little
about the
bit.
prion disease. For a long time we thought infection disease can be caused only by bacteria or viruses. But now we found so-called proteins that are natural to our brain. But then this protein can have different shapes. A protein is a sequence of amino acids, and it folds in different shapes. Now imagine this can have two shapes. This protein can have two shapes. One shape we are familiar with, we can break it down, we can reuse it. The other shape is not familiar to us. We cannot do anything about it, it accumulates. It's good indication actually the Alzheimer might have some relationship to that. But
Sure.
with the mad cow disease or prion disease, the specific thing about that is that the molecule that is diseased of that protein actually has an enzymatic activity on the normal protein shape, and it turns it like that. Like, imagine same protein, but one of them turned the good one to bad one. Zombie protein. That's the definition of a zombie protein that makes the good protein a bad protein, and the bad protein cannot get rid of. It accumulates. Then when it accumulates to a certain point, it is like, use my friend, somebody comes and closes your anus, cannot get rid of the waste, and you're going to explode, and that cell die. And that is what the prion disease. In many of these prion disease that is actually more known in other things, that process, that protein is in the brain. So practically what happens is that you eat the brain of the infected animal. That is how you are contracting. Okay? But we should come back and have a good conversation about the prion disease, because talking about zombies, the cannibals get that.
I'll add that to our
Okay,
next
that is so. We are going to talk hopefully sometime next about the Kuro disease and cannibalism and the effect it has on us. Well, this is Dr. Abbasi. It has been a pleasure to have the Essence of Medicine, the Halloween edition.
Yes.
Thanks for joining, guys.
Have a happy Halloween.
Be safe.
And be spooky.